In this video, we will explain how IP addresses work and why they are essential for communication on the internet. Every time you open a website, watch a video, send a message, or use an app, your device exchanges data with other devices across a network. For this communication to happen correctly, each device needs to be identifiable. That is the role of the IP address. An IP address is a numerical address assigned to a device connected to a network. Its purpose is to identify the device and allow data to be sent to the correct destination. In simple terms, if the internet is compared to a postal system, the IP address is the address written on the envelope. Without it, the data would not know where to go. The term IP stands for Internet Protocol. The Internet Protocol is a set of rules that governs how data travels across networks. An IP address is therefore an address used by this protocol to identify devices. There are two main functions of an IP address. First, it identifies a specific device on a network. Second, it indicates where data should be delivered. This means that when one device sends information to another, the IP address helps the network know both the sender and the receiver. A common example of an IP address in IPv4 format is 192.168.110. This is a numerical label made of 4 parts separated by dots. To understand why IP addresses are necessary, let us consider what happens when you visit a website. When you type a website name, such as example.com, your device wants to retrieve the data stored on the server that hosts that website. However, the network does not primarily use names to identify destinations. It uses IP addresses. So before the communication begins, the domain name must be translated into an IP address. This is usually done by the Domain Name System or DNS. Once the IP address of the destination server is known, your device can send a request to that address. The server then sends the response back to your device using your own IP address as the return destination. This shows that IP addresses are necessary because they allow data to be directed accurately between devices. Data does not travel across the internet as one large block. It is divided into smaller units called packets. Each packet contains useful information, but it also contains addressing information. In particular, it includes the source IP address, which identifies the sender, and the destination IP address, which identifies the receiver. When a packet moves through the network, routers examine the destination IP address and decide where the packet should go next. This process continues step by step until the packet reaches its final destination. When the receiving server sends a response, it creates new packets. In those packets, the source and destination are reversed. The server becomes the sender, and your device becomes the destination. This is how a complete exchange of data takes place. Not all IP addresses are used in the same way. It is important to distinguish between public and private IP addresses. A public IP address is used to identify a network on the internet. It is generally assigned by an Internet Service Provider, or ISP. A private IP address is used inside a local network such as a home, school, or company network. For example, within a home Wi-Fi network, a laptop, a smartphone, and a smart TV can each have their own private IP address. The router connects this local network to the internet. Internally, it manages private IP addresses. Externally, it uses a public IP address. This organization allows many devices in the same network to access the internet through a single public connection. The router plays a central role in network communication. Inside the local network, it communicates with devices using their private IP addresses. At the same time, it communicates with the internet using the public IP address of the network. To make this possible, routers often use a mechanism called NAT, which stands for Network Address Translation. NAT translates private IP addresses into a public IP address when data leaves the local network, and it performs the reverse operation when responses come back. This allows multiple devices in one home or office to share a single public IP address efficiently. Without this mechanism, each device would need its own public IP address, which would be much less practical. There are two main versions of IP addresses in use today: IPv4 and IPv6. IPv4 is the older and more familiar version. It uses addresses made of 4 numerical parts, such as 190, 2.160, 8.1.10, IPv. 4 can provide around 4.3 billion unique addresses. At first, this seemed sufficient. However, with the growth of the internet and the increasing number of connected devices, IPv4 addresses became limited. To solve this problem, IPv6 was introduced. IPv6 uses a much longer format, for example, 2001 0db8 85a3 00000 0000 8a2e 0370 7334. Because it uses a much larger address space, IPv6 can support a very large number of devices. Although IPv6 looks more complex, its purpose remains the same. identifying devices and allowing data to reach the correct destination. Let us summarize the process with a simple example. Suppose you want to open a website. You type the domain name into your browser. DNS translates that name into an IP address. Your device creates packets containing the destination IP address of the server and your own source IP address. Routers forward these packets across the network. The server receives the request and sends response packets back to your device. Your browser receives the data and displays the website. At every stage of this process, IP addresses are necessary for identifying where the data comes from and where it must go. An IP address is a fundamental element of digital communication. It allows devices to be identified on a network and enables data to be delivered to the correct destination. It is used by routers to guide packets, by servers to send responses, and by devices to communicate across both local networks and the internet. To summarize, an IP address identifies a device, it helps data find its destination, it exists in public and private forms, it is used in both IPv4 and IPv6 formats, and it is essential for internet communication. Without IP addresses, modern networking would not function in an organized or reliable way. That is how IP addresses work.